Hi guys, in this session we are going to discuss BJT fundamentals, right? So BJT, Bipolar Junction Transistor, that means in this two PN junctions will be coming into the picture. Have you understood this, right? So actually what is BJT, right? So if in interviews also, if anybody asks, interviewer asks, what is BJT? So the first and foremost answer must be BJT is current controlled current device. Current controlled current device. Triple C device. Triple C device. That means current controlled current device. Right? So that means different definitions may be there, but the accurate definition for BJT is a current controlled current device. Current controlled current device. Current controlled current device. That means what does it mean? What is meant by current controlled current device? Means the output current is controlled by input current. That means the output current is function of input current. That means the output current is function of input current. That means what does it mean? If any incremental change in input current, the corresponding incremental change in output current can be found. Any decremental change in input current, the corresponding decremental change in output current also can be found. With this discussion, we can conclude that the output current is function of input current. That means I will write down here. So any incremental change in input current means like this. So the corresponding incremental change in output current can be found. In the same way, so any decremental change in input current, the corresponding decremental change in output current can be practically found. That is the reason why it is called current controlled current device, triple C device. Have you understood this, right? So from this we can conclude that, so the output current is dependent variable. This is dependent variable, and input current is, what is input current? Input current is independent variable. Independent variable. Have you understood this, right? So the output current is dependent variable and input current is an independent variable. Have you understood this, right? So then what is the basic function of the transistor, right? So the basic function of the transistor is amplifier. That means it can amplify the signal to the desired level without disturbing other parameters like frequency and phase shift. Right? So that means basically the input signal is represented, most of the real-time signals are analog in nature, which varies continuously with time. Have you understood this, right? So that means what are the physical parameters are inseparably linked with the analog signal or sinusoidal signal. So amplitude, frequency and phase shift. While amplifying the signal to the desired level, the frequency, the other parameters, that is frequency and phase shift, should remain constant. That is the prime motivation of amplification, and this can be achieved by using transistor. Hence you can certify that transistor or BJT is the basic function of BJT is amplifier, amplification, right? So I'll write down here the basic function of transistor is amplifier, right? So the basic function of transistor is amplifier. This one. This is another one more point. And next one is we will try to derive the function of the transistor from its name, right? So the prefix trans stands for signal transfer property. Have you understood this, right? So the prefix trans stands for trans. This one is transfer, that means signal transfer property. Signal transfer property. And so the prefix ester This is signal transfer property, and the prefix ester categorizes it into general family of resistors. That means ester categorizes it into general family of resistors. General family of resistors. That means, what does it mean? That means the prefix trans stands for signal transfer property, and the prefix ester categorizes it into general family of resistors. That means if you combine these two terms, that is nothing but transistor. Transistor which transfers signal from low resistance path to high resistance path. Transfers signal from low resistance path to high resistance path. Have you understood this? Right? So, it transfers signal from low resistance to high resistance path. That means, so I have already mentioned that, so two junctions will be coming into the picture in transistor, bipolar junction. Two PN junctions will be coming into the picture, right? So if we want to establish low resistance path along the input circuit or along the input junction, what is required? So low resistance path along the PN junction means it must be forward biased. That means, so in order to achieve the basic function of the transistor, that is amplification or faithful amplification, right? So input always must be forward biased to establish the low resistance path. Input always must be forward biased, and so in this case, to establish high resistance path, output always must be reverse biased. Have you understood this? This is the first and foremost condition to be satisfied to use transistor as an amplifier. Have you understood this, right? It transfers a signal from low resistance path to high resistance path. Both types of resistances will be coming into the picture. That is the reason why it is categorized into general family of resistors. Have you understood this? To establish low resistance path along the input circuit, input must be forward biased. And to establish high resistance path along the output circuit, output must be reverse biased. That is these conditions must be satisfied to use transistor as an amplifier. Have you understood this, right? So basically, transistor is a three-terminal device that we know. Have you understood this, right? So the next one is why transistor, the very important for competitive examinations is why transistor is called a diffused transistor. Have you understood this, right? So diffused transistor. Why transistor is called diffused transistor, right? This is diffused transistor. Have you understood this, right? So transistor have three terminals, that means emitter, base and collector. Right? So the emitter current is due to majority charge carriers and is of diffusion type. In semiconductors, how many types of currents will be coming into the picture? Two types. One is diffusion current and the second one is drift current. Drift current exists in conductors also, but diffusion current does not exist in conductors. Diffusion current exists only in semiconductors. Right? Two types of current components will be coming in. One is diffusion current due to concentration gradient and drift current due to external field. Have you understood this, right? So in this case, the first current component IE is due to majority carriers. IE is due to majority carriers and is of diffusion type. And is of diffusion type. And is of diffusion type. And the second one is IC is also due to majority carriers and is of diffusion type. Right? And base current IB is also due to majority charge carriers and is of diffusion type. Have you understood this? This base current is also known as recombination current. recombination current, right? So that means what you have understood from this, all the three major current components, that means IE, IC and IB, are due to majority charge carriers and are of diffusion type. That is the reason why transistor is called a diffused transistor. Have you understood this? This is very important for so competitive examinations as well as in interviews also. Normally they will question you. So why transistor is called just like that? Why transistor is called diffusion transistor? Right? So the main reason is all the three current components are due to majority charge carriers and are of diffusion type. That is the reason why transistor is called diffused transistor. As simple as that. Have you understood this, right? So one more current component will be coming into the picture in transistor, that is due to minority carriers, right? So that is IC naught. IC naught is due to minority carriers, and is of drift type. That means only one current component exists in the transistor is of drift type. That is IC naught. Drift current means drift current is due to external field, right? So this IC naught is due to thermal energy, external temperature. Followed. So this current is due to thermally liberated charge carriers. Thermal energy is only the source to cause IC naught. Have you understood this? Reverse saturation current or thermally liberated carrier current or minority carrier current is of drift type. Why? Because that is due to external thermal energy. Have you understood this? This is very important. All three major current components are of diffusion type, but only one current component exists in the transistor, that is of drift type. That is external thermal energy causes this current component. Have you understood this? Right? And next one is, let us discuss about transistor terminals. Right? BJT terminals. The first one is emitter. So emitter, which emits majority charge carriers into the base region. The basic function of emitter is to inject majority charge carriers into the base region. Have you understood this, right? So I will write down here. So it injects majority carriers into the base region. Majority carriers into the base region. Right? So that is the basic function of emitter. And emitter is heavily doped, more heavily doped when compared to other two sections. That means collector and base. Have you understood this? And next one is, it is physically moderate in size. Physically moderate in size. Moderate in size. These are the physical characteristics of base. The basic function of emitter is which emits or injects majority charge carriers into the base. And second one is heavily doped, more heavily doped. And the third one is physically moderate in size. Next one is collector. Right? So collector that collects majority charge carriers from the base region. Right? So it collects majority charge carriers, from the base region. That is the basic function of the collector, which collects majority charge carriers from the base region. Right? So, and it is moderately doped. Here we have to carefully observe, moderately doped. So, here two cases are there. Why it must be moderately doped? Immediately the next question is why it must be, that means emitter is heavily doped. Why it must be heavily doped? To inject more number of charge carriers into the base region, it must be heavily doped. That is the reason why the emitter is characterized by heavy doping concentration. Have you understood this? And at the same time, why collector must be moderately doped? Two reasons are there. One is, if it is lightly doped, right? So then what happens? The conductivity of collector decreases. That is the problem with the light doping. Have you understood this, right? So if collector is lightly doped, then the conductivity of collector decreases, which is not up to the mark. The conductivity becomes very less, right? That is why, hence, it should not be lightly doped. That is the first thing. And the second one is, if it is heavily doped. On the other hand, if it is highly doped, then the operating voltage of transistor decreases. Operating voltage of transistor decreases if it is heavily doped. That is, more number of charge carriers are readily available. And if the reverse bias voltage increases, then so junction breakdown occurs at lesser potentials. Junction breakdown occurs at lesser potentials. That is why, that means if it is characterized by heavy doping concentration, then definitely the operating voltage of transistor, operating voltage decreases. Right? So that means with this we can conclude that to have reasonable conductivity and operating voltage, transistor must be moderately doped. Have you understood this, right? Why? This is very common question raised by our elders in interviews basically, as well as in competitive examinations also. Why collector must be moderately doped? If it is, that means the reason is, why, if it is lightly doped, then the conductivity is not up to the mark. Have you understood? The current conduction capability of the collector becomes less. Have you understood this? Next one is, if it is, on the other hand, if it is highly doped, then the operating voltage of the transistor decreases. To have reasonable conductivity and reasonable operating voltage, it always must be moderately doped. Have you understood this, right? And so next one is, it must be made large, physically large. Why it must be made physically large? To dissipate more heat. That means next one is physically made large. Physically large in size to dissipate more heat. These are the characteristics of collector. And next one is, the very important section is base. Have you understood this, right? So base, next section, base. So what is the basic function of the base? Have you understood this, right? So the basic function of base is, the majority charge carriers are transported through the base region. The majority carriers injected by emitter are transported through the base region. That means it is capable of transferring majority charge carriers from emitter to collector through the base region. Have you understood this, right? So that is the basic function of base. The majority charge, it transports majority charge carriers. Transports majority charge carriers from emitter to base, emitter to collector. Have you understood this, right? And it must be lightly doped. So its physical characteristics are, it must be lightly doped and made thin. It must be lightly doped and made thin. Physically very small in size and lightly doped. Have you understood this, right? So if it is lightly doped, because of its doping concentration is very, very less, lightly doped, to increase emitter injection efficiency. Further, why it must be lightly doped? To increase the emitter injection efficiency. So that means the emitter injection efficiency increases because of light doping concentration. Injection efficiency increases. Have you understood this? And made thin. So what is the advantage of That means it is made thin. Alright? So to reduce rate of recombination, to decrease rate of recombination. Right? So these 2 points must be carefully observed. To decrease rate of recombination. Have you understood this, right? So it is lightly doped to increase emitter injection efficiency, and at the same time it is made thin to decrease rate of recombination. And among 3 sections of the transistor, base plays vital role, very important role. Why? Do you know why? Why means, so the actual operating point of the transistor lies in the base region. That is the reason why base plays vital role. Have you understood this, right? So the actual operating point of the transistor, lies in the base region. That is why, so base plays vital role among 3 sections. Have you understood this, right? So, and next one is base transportation factor is there, beta star. Beta star is different from beta. So what is beta? Beta is current gain in CE configuration, that is different. Whereas beta star is base transportation factor. Base transportation factor. Base transportation factor. So this indicates, so what base transportation factor tells us? It tells us about how effectively base transports the majority charge carriers from emitter to collector region. Have you understood this, right? So there is a measuring parameter should be there. Suppose if some function is assigned to the device, immediately it's some measuring parameter must be there to observe how effectively it is performing its job of operation. Have you understood this? In the same way, what is job of operation of the base? It transports majority charge carriers from emitter to collector through it. Have you understood this, right? So, and how effectively it transfers majority charge carriers from emitter to base is observed by this factor. That means I will write down here how effectively base transports majority charge carriers. Transports majority carriers from emitter to base is observed by base transport factor. Have you understood this, right? So this is very important. And base transport factor is, that means the ideal value of base transport factor is 1. Ideally beta star is 1. Have you understood this? But practically beta is approximately equal to, beta star is approximately equal to 1. Have you understood this, right? Another most important thing regarding transistor operation is, right? So the diffusion length of the charge carrier, the diffusion length, the distance traveled by the charge carrier must be more than the base width. Then only the charge carriers can cross the collector junction and enters into the collector region. Have you understood this? This is the first and foremost condition to be satisfied to operate the transistor properly. That is why this condition must be carefully observed. Have you understood this, right? So the basic condition to be satisfied, for proper operation of transistor, as an amplifier. What is the condition? The diffusion length of the charge carrier through the base region must be much larger than width of the base region. Have you understood this, right? So the diffusion length, that means the distance traveled by the charged particle before it participates in recombination process. followed before it disappears, followed must be greater than, so width of the base region. That means, so schematically this can be represented like this. So this is emitter and this is collector, and so the pins, I will write down here, this is emitter and this is collector and this is base region and this is emitter junction and this is collector junction. Have you understood this, right? So the diffusion length of the charge carrier must be much greater than the width of the base region. This is nothing but width of the base region, and this is nothing but diffusion length of the charge carrier through the base region. Have you understood this, right? Now this condition was satisfied. So schematically, if this condition was satisfied, then only the transistor can be operated properly. Otherwise, it cannot be operated properly. Why? Because no change. That means if this condition fails, then what happens? No charge carrier can reach the collector junction. Then how transistor works? What is the basic function of the transistor? So it transfers the signal from low resistance path to high resistance path. That means from emitter to collector region. Have you understood this? Then only it functions as an amplifier. Otherwise, it won't function as an amplifier. Right? In order to use it as an amplifier, this condition must be satisfied. Have you understood this? Right? So, next one is diode equivalent of transistor. Diode equivalent of a transistor. Right? So, transistor is equivalent to two diodes connected back to back. Two diodes connected back to back. Suppose, let us say, suppose PNP transistor. PNP transistor. That means, so the diode equivalent of PNP transistor can be represented like this. This is diode equivalent. That means, see, here, I will write down here. So, schematically, this is PNP. Have you understood this? This is P, from here to here, this is PN junction, and reverse side PN junction. Followed from this side to this side, this is PN junction. That's what we have done here. Have you understood this, right? So transistor is equivalent to two diodes connected back to back, as shown in the figure. Have you understood this, right? So this acts as emitter, and this is base, and this is collector. And if you connect practically two diodes connect back to back, will it function as a transistor? Never. No, that is never possible. If two diodes connected back to back practically will never function as a transistor. The reason is there is no bonding force between emitter and a collector. Have you understood this, right? Even if the bonding force is created, followed, even if the bonding force is created externally, but a large base will appear between emitter and a collector, followed, and hence, so transistor will never function as an amplifier. Large base, what is the problem with a large base? The charge carriers cannot cross the base region. Followed, they will disappear in the base region itself. That is the reason why base is made very thin. Have you understood this? But that condition fails if you connect two transistors back to back. Have you understood this? Large base will appear between emitter and collector, which never allows charge carriers to cross the collector junction, and hence it will never function as a transistor if two diodes connected back to back. But that is equivalent circuit only. For our representation only, we are viewing like this: two diodes connected back to back. For research work, not for practical purpose. Have you understood this, right? So, next one is various regions of transistor operations. Various regions of transistor operations. That means JE, region of operation, and JE, JC, application. Right? So application. That means the first one is active region, let us say. if the transistor is said to be operated in the active region. Then JE must be, emitter junction must be forward biased, and collector junction must be reverse biased. And if we operate the transistor in active region, that means a linear portion, so then it acts as an amplifier. Then transistor can be used as an amplifier. Have you understood this, right? So next one is saturation region. Saturation region. That means, so to use transistor in saturation region, then both the junctions, both emitter junction and collector junction must be reverse biased. In saturation region, transistor can be used as on switch. On switch. Right? So next one is cutoff region. Cutoff region. Right? That means cutoff region means if both the junctions are reverse biased, both JE and JC are reverse biased, then it is said to be operated in the cutoff region. In this region, transistor can be used as off switch. Have you understood this? On the other hand, one more region is there, that is inverse active region. Inverse active region. Inverse active region. That means in this case, JE is reverse biased and JC is forward biased. JE is reverse biased and JC is forward biased. So what is the application of inverse active region? So that means in this, transistor can be used as attenuator. Attenuator. Have you understood this, sir? Under normal circumstances, transistor will never operate in inverse active region. Only it is operated in the first three regions only. Active region, saturation region and a cutoff region. That means in active region, if you operate transistor in active region, hence it functions as an amplifier. And if it is used in saturation region, if it is connected in saturation region, then can be used as on switch. And if it is used in cutoff region, then can be used as off switch. Have you understood this? Now let us observe the various conditions for various regions of operation. Suppose PNP transistor in active region. PNP transistor in active region. That means, what does it mean? So active region means JE must be forward biased and JC must be reverse biased. This is the condition to be satisfied to use transistor in the active region. Right? So that means transistor diode equivalent circuit is two diodes connected back to back like this. Have you understood this, right? So this must be forward biased just by connecting positive terminal of the battery to the anode and negative terminal of the battery to the cathode. And similarly, this also can be reverse biased. How this can be reverse biased? By connecting positive terminal of the battery to the cathode terminal and negative terminal of the battery to the anode terminal. Have you understood this? This is positive terminal and this is negative terminal. This is VEB, emitter base voltage, and this is VCB, collector base voltage. Have you understood this? This is emitter and base collector. Right? So from this, we can derive the condition for active region. How we can derive the condition? The emitter is at positive terminal. Just look at this. Emitter is at a positive terminal. That is higher potential. And base is connected to negative terminal. That means at a lower potential. Right? So that means VE is less than VB. VE from this. So VE is less than VB. And so output side. So base is connected to positive terminal and collector is connected to negative terminal. That means what does it mean? So VB is greater than VC. Have you understood this? VB is greater than VC. Right? So if you combine both the conditions, then what we will get finally? VE is less than VB is greater than VC. This is the condition must be satisfied to use transistor in the active region. Have you understood this? These conditions are very important for competitive examinations. right? So, and next one is saturation, PNP transistor in a saturation region. PNP transistor in saturation region. Transistor in a saturation region. So, if you want to use transistor in saturation region, so what is the condition must be satisfied? JE must be forward biased and JC must be reverse biased. This is the condition, both the junctions must be forward biased, not reverse biased, forward biased. Both JE as well as JC must be forward biased. This is the condition must be satisfied to use a transistor in a saturation region. Have you understood this? Let us connect. So, this is two diodes connected back to back. This is base terminal. And how this becomes forward biased? Just by connecting positive terminal of the battery to the anode and negative terminal of the battery to the cathode. Similarly, so this becomes forward biased by connecting negative terminal of the battery to the cathode and positive terminal of the battery to the anode. Have you understood this? This is plus minus VEB and minus plus VCB. Right? So now look at, that means try to derive the condition for saturation region. That means VE, emitter is at higher potential and base is connected to the negative terminal. That means lower potential. That means VE is less than, VE is greater than VB. VE is greater than VB. And from here, so output side, base is connected to negative terminal and collector is connected to positive terminal. That means base is less than, VB is less than VC. Have you understood this? If you combine these two conditions, then what we will get finally? VE is greater than VB is less than VC. Followed. This is the condition must be satisfied to operate the transistor in saturation region. Have you understood this? This condition. And next one is cutoff region. Cutoff. Cutoff. PNP transistor in cutoff region. PNP transistor in cutoff. That means, so what is that? JE must be, both the junctions must be reverse biased. That is, JE must be reverse biased and JC also must be reverse biased to use transistor in cutoff region. Right? So let us connect. So this is diode, two diodes connected back to back. And this is how this becomes reverse bias, just by connecting negative terminal of the battery to the anode and positive terminal to the cathode. Similarly, how this becomes reverse biased? By connecting negative terminal of the positive terminal of the battery to the cathode and negative terminal of the battery to the anode. This is minus plus VEB and plus minus VCB. Now try to derive the condition from this. Right? So what is the condition? VE is less than VB. VE is less than VB. And next one is, in this case, VB is greater than VC. VB is greater than VC. If you combine both, VE is less than, VB is greater than VC. This is the condition must be satisfied to operate the transistor in a cutoff region. Right? Thank you.